video, we discussed the battery capacity required to power TV lights and electric fan. Noong huling video, tinalakay natin ano yung battery capacity na kailangan para patakbihin yung TV, ilaw, at electric fan o the fan. Ang nakuha nating dalawang numero ay 600 watt-hours at 50 ampere-hours. The numbers we got were 600 watt-hours and 50 ampere-hours. So the next problem now is how do we actually charge a 600 watt-hour battery? There are two methods for this. One is the watt-hour method, and the other is the ampere-hour method, which I'll describe right now. So 600 watt-hours divided by 4 hours, and you get 150 watts. This is the minimum solar panel power required to fill up a 600 watt-hour battery. Now, you might be wondering, where did we get the 4 hours? 4 hours is the average time that the sun is on in the Philippines. In summer, you get as much as 6 hours of sun time, and then on the rainy season or cloudy days, you get as little as 2. So on the average for the whole year, we've studied that, and you get 4 hours of sunlight every day for the whole year. Now, looking at the amount of current required from the solar panel, we divide 150 watts by 12 volts, which is the system battery voltage, and you get 12.5 amperes. So there's a slight problem here. If you look at the maximum power that a 100 watt panel can give, it can give 18 volts at 5 amps. So one 150 watt panel cannot simply give you 12.5 amps. So to solve this problem, you will need to combine 3 100 watt panels of 5 amperes each to overcome this 12.5 ampere requirement. So that's the first method, and it shows that you need 3 times 100 watt solar panels. In the second method, we divide 50 ampere hours by 4 hours, and we get 12.5 amps. So 12.5 amps is divided by 8 amps to get 1.6 solar panels. Now, where did we get the 8 amps? That's the maximum current that a 250 watt solar panel can give. So that means in this method, we would require 2 times 250 watt solar panels. Now, what if we told you we have a technique where you can reduce the solar panel power required without spending additional pesos and without sacrificing the performance of the system? So here is what you do. Instead of using 12 volt battery, we combine 2 of those in series to form a 24 volt battery. Now, because you need 24 volts now, the amount of ampere hours is reduced by half. This becomes 25 ampere hours. So the battery capacity will also be reduced to 25 ampere hours. If this becomes 25 ampere hours, then the solar panel power current will become 6.25 amps. At 6.25 amps, one panel will be enough to charge the battery system. So that's how you reduce the solar panel power required without sacrificing the performance. In the last installment of this video series, we'll discuss how much all of this will cost, and we'll give you the remaining 2 tips in reducing the overall cost of the system by reducing the electric fan power required and totally eliminating the need for an inverter.